less than or equal to 12. I could make 2 brownies. I could be stingy with my bake sale. So there's lots and lots of possibilities here. And the big idea is only the 1, 2, 3, 4, 5 that we came up with. There's a lot more possibilities. We've just listed a few. All right, so let's go ahead then and look at your notes for 2.8. In example 1, it says, which ordered pair is a solution of the linear inequality 3x plus 4y is greater than 8? Can anybody describe what would we need to do to figure this out? Plug them in. Right, exactly. So let's do this. You're going to take 3 times the x value plus 4 times the y value. And what I like to do is, since I'm testing and I'm not sure, I like to put a question mark above my inequality symbol because that's what I'm trying to figure out. So then this gives me 18 minus 12. Is 6 greater than 8? No. Then let's plug in for letter B. I would do 3 times 0 plus 4 times 2, and then I'm going to put a question mark here. Is that greater than 8? 0 plus 8? Is 8 greater than 8? No. All right, letter C. 3 times negative 2 plus 4 times negative 1. Is that greater than 8? Definitely no. And then we get 11 is greater than 8. Yes. Okay. Any questions on example 1? All right, then in the box here, graphing a linear inequality. Step 1, determine whether the boundary line is solid or dashed. And what I want you to notice is with solid, has the or equal to part. And yesterday I was reading through my textbook, teacher book, and it had a suggestion. It said for students that maybe have difficulty with remembering things, that if you can remember that the less than is missing the or equal to, it's dashed, it has less that you're drawing. And I thought, oh, that's kind of interesting. So solid has the or equal to, dashed has less than that, so it's not the full line. Step 2, change the inequality symbol to an equals and graph the boundary line. Step 3, choose a test point not on the line. If true, shade where the test point lies. If false, shade on the opposite side. Something I want to mention is that we have these beautiful notes. The notes are reference materials for you. So when you're doing your homework and you think, I'm stuck, reread your notes, okay? We have everything on there that you need. And when you're given these steps, you should be with every problem you are graphing a linear inequality. You should be going through step 1, step 2, step 3, over and over and over again. Because by the time you're done with 10 of them, this checklist is in your head. But if you never look at it and you're trying to remember, now what do I do? There's nothing there for you to recall. So go to your checklist over and over and over again. Okay, so now you have the checklist, even though I've moved to my next screen. Example 2 says, graph linear inequalities with one variable. So we'll just go around the room, and I'm going to keep asking you the same questions over and over again. So Henry, when I want to graph, what is step 1?
Determine whether the boundary is solid or dashed.
All right, so Megan, is this solid or dashed?
It is solid.
It is solid. Okay, so step 1, determine whether you have a solid or a dashed line. Hannah, what is step 2? Good job. Step 2. Change the inequality symbol to an equal sign and graph it. So McKenna, what kind of line is y equals -2? Good job. This is a horizontal line. So I'm going to go to y is -3. It's solid. I'm going to make a solid line. And then we're going to do a test point. A test point is not on the line. So I'm going to pick, say, 0, 0. And you go to the inequality. Now there's no x, so I have nowhere to plug that in. So it says 0 is less than or equal to -3. Is this true or false? This is false, so I don't shade where the test point is. I shade on the opposite side. Okay? All right, letter B, x is greater than 2. So Andrew, what is step 1?
Determine whether it's a straight line or not.
Okay, solid or dashed. So Zach, is this solid or dashed?
It is dashed.
It is dashed. Okay. Carmel, what is step 2?
Change the inequality symbol to an equal and graph the boundary line.
Awesome. Step 2, change the inequality symbol to an equals and graph that boundary line. So Jaslyn, what is the graph of x equals 2? What kind of line? It's a vertical line. So that's not real hard for us. So let me make a dashed through x is 2. Make sure you guys are putting arrows on the end of your line. Then, Elena, what is step 3? Okay, use a test point. Now, the test point, remember, has to be not on the line. 0, 0 is our favorite one, but if it goes through 0, 0, you have to pick another point, and there's infinitely many to choose from. So I'm getting 0 is greater than 2. So Henry, is 0 greater than 2? No. So I don't shade there, I shade over to the right. Okay? All right, here we go. Example 3 says graph y is greater than -2x. So Megan, what is step 1?
Decide whether it's dashed or solid.
Okay, decide whether it is dashed or solid. So Hannah, in letter A, y greater than -2x, is that dashed or solid? It's dashed. All right, Zach, what is step 2?
Step 2 is change the inequality symbol to an equal sign and graph the boundary line.
Awesome. Okay, step 2, change the inequality symbol to an equal sign and graph that line. Now, y equals -2x. We know how to graph this. The y-intercept is 0, and my slope is -2. So I go down 2, right 1, down 2, right 1. It's dashed. Okay, so step 1, determine whether it's a solid or dashed boundary line. Step 2, change the inequality symbol to an equals and graph that line. Andrew, what is step 3?
Test point.
Good, pick a test point. Now the bummer is I can't use 0, 0 because it goes through 0, 0. Your test point has to be not on the line. So it really doesn't matter what point you choose, just as long as it's not on there. The recommendation of your textbook is let one of the x or y values be 0, because 0 is easy to work with. So I'm going to choose 3, 0. Excuse me. So y is 0, x is 3. Then McKenna, is 0 greater than -6? Yes. So I'm going to shade where the test point is, okay? All right, here we go. Letter B, 5x minus 2y less than or equal to -4. Jaslyn, what's step 1? Okay, solid or dashed? So this is solid. Carmel, what's step 2?
To change the inequality symbol to an equal and graph that.
Okay, change the inequality symbol to an equals and graph the line. Guess what? We talked about this earlier in the chapter. If it's in standard form, your equation's in standard form, do the intercept method. You do not have to do extra work of y equals mx plus b. You're certainly welcome to do the extra work and graph it that way, but you don't have to. So if I let x be 0, I get negative 2y equals negative 4. Divide by negative 2, and y is 2. Now we're going to let y be 0, and I get 5x equals negative 4. Dividing by 5, x is negative 4/5. Okay, that's not pretty, but it's certainly doable. Negative 4/5 is almost to negative 1. It's solid. Now the question, Elena, what's step 3? Use a test point. Can I use 0, 0? Yes, because it's not going through 0, 0. So I'm getting 0 minus 0 is less than or equal to negative 4. Anyone, is 0 less than or equal to negative 4? No. Right? 0 is not smaller. So I'm going to shade on this side. Okay? All right, so are we getting the hang of this? Okay. So graphing a linear inequality, step 1. Determine whether you have solid or dashed. Step 2. Change the inequality symbol to an equals and graph that equation. Step 3. Pick a test point not on the boundary line. Shade, if it's true, shade where the test point is. If it's false, you shade on the opposite side. Okay. Now we're ready to take it to a new level. This is exciting. If I want to graph an absolute value inequality, I'm actually going to use the same 3 steps. Step 1, solid or dashed. So Henry, is this one solid or dashed? Dashed. Good job. So then I'm going to change this to y equals negative 2 absolute value x minus 3 plus 4. Guess what? What you just did for homework was graphing these v's, these absolute value equations. So I know the vertex is 3, 4, and I know the slope, or a, is negative 2. Okay, so let's plot. I have 3, 4, and then I use the slope. Down to right 1, down to right 1. This is dashed. Make sure on your V's that you have arrows on the ends. Okay, so we're going through the exact same process we just did. There's just one new little piece to it. Step 1, dashed or solid. Step 2, change the inequality symbol to an equals and graph the V. Step 3, when I do the test point, I just need to make sure the test point is not on that V, so I'm still going to do 0, 0. The difference is you're either inside the V or outside the V. That is the only difference where you shade. So let's try it. I get 0 is greater than negative 2, absolute value, 0 minus 3 plus 4. Well, 0 minus 3 is negative 3, but the absolute value of negative 3 is 3. Is 0 greater than negative 2? Yes. Now, here's 0, 0. So it's on the outside, so we're shading on the outside of the V. Okay, really simple. Very, very simple.